Introduction to Astronomy. The first picture ever taken of the Earth from outer space. Carl Sagan is a very famous scientist who brought to the forefront a lot to do with the world as well as the universe. Everything that you have known, that you've done, everyone that you have ever known, everyone who's ever lived, has happened on this pale blue spot in space. This speck of dust suspended in a beam of sunlight. Let's say, for example, you're trying to explain how to get to the Earth from somebody who's not from around here. How would you tell them? This is my introduction to the scope and scale of the universe. Maybe it goes without saying, but perhaps everything begins with the universe. The biggest thing that there is, it's everywhere. It fills up everything. It is all time and space. There is nothing that exists outside of it. See that small little blob there? It doesn't actually exist outside of the universe. It's part of the universe. Because nothing exists outside of the universe. It is everything, everywhere. So, what exactly is the universe? Okay, so let's tell our alien friend, okay, start in the universe. Easy done, we're already there. But what's next? What else can we tell him? We can tell him about that there are galaxies. Perhaps we can even remember that we live in the Milky Way, which is excellent because our galaxy, the one that we live in, is called the Milky Way because the ancients, when they looked at the night sky, decided that it looked like the gods had spilled milk across this beautiful stretch of sky. If you were able to zoom out of our galaxy and look at it from above, it would appear like this. We live in a very common type of galaxy. It's called a spiral galaxy. We live on the outskirts of one of those arms coming off from the center. Now, of course, this isn't a real picture of our galaxy. We actually don't have the technology to fly out far enough and snap a picture of it, but we can still know what this is and what it looks like. We can look at other galaxies and see what they look like, and then we can analyze the stars in our own galaxy, calculate the shape and the motion of our neighborhood in space, and voila! It looks like the spinning thing before you. They've even calculated that there probably is a black hole in the middle of our galaxy. If you were to look at a galaxy from the side, it would look like this. What does this teach us about galaxies? They are gigantic when you measure them across, but not very thick when you look at them from the side. That bright light in the center is a dense cluster of stars attracted to the black hole in the center of the galaxy. Humans have been able to do this with some technology, like telescopes, that help us appreciate the beauty of galaxies up close. So here are some galaxies that we can look at. There are different filters that we can use, and those will help us see various different types of electromagnetic radiation. So we could see in the infrared, the ultraviolet, the X-ray, the visible spectrums. And sometimes those filters change the color of the galaxies, but they are still very, very pretty. This particular galaxy here is galaxy NGC 4414. This is true color, and it shows how the galaxy would look to your naked eye. This galaxy is called M81. This is a whirlpool galaxy. It's one of the most photographed of all distant galaxies. This is the same galaxy, just closer up. If you were in charge of naming this galaxy, what would you call it? The real name for this galaxy is the Black Eye Galaxy. This is galaxy M31. All of those bright dots in these galaxies are stars or kind of related to stars. It could be quasars and things like that. I don't know the name of this galaxy, but it's cool because it's green. Might be more than just a filter making it green, but I don't really know. This is a cool galaxy, but I don't know the name of it either. What would you call this galaxy? This galaxy's name is Sombrero Galaxy. It's a great view of what a galaxy looks like from the side. This is the same galaxy, but with a different filter, which highlights infrared radiation. Remember, infrared radiation is otherwise known as heat. I don't know the name of this one. It could be M31, but viewed through a different set of filters. This is the Cartwheel Galaxy. This is the Whirlpool Galaxy again, but this time you have a better view of how it's absorbing its neighbor galaxy. The next few pictures are interactions between galaxies. These are the antenna galaxies, which is a pair of colliding galaxies. These galaxies are known affectionately as ARP148, another collision. To me, it looks like Pac-Man breathing fire. What do you think this one's called? It's called the Tadpole Galaxy and is the result of a galaxy collision. This particularly photogenic pair of galaxies is known as ARP273, but its common name would be the Rose. This is the same galaxy as shown before when we first started talking about the galaxies. There are three different categories or classifications of galaxies. There's spiral, elliptical, and irregular. This would be an example of a spiral galaxy. It has the little legs swinging off of it, it's spinning. This is an example of an elliptical galaxy. This is Centaurus A. And this is another view of Centaurus A with a different filter. It is an elliptical galaxy. This is an example of an irregular galaxy known as the cosmic bird. I would have called it the Tinkerbell galaxy. I don't know what this one's called, but I think it kind of looks like a bear, so I would call it the cosmic bear. This is one of our nearest neighboring galaxies, the Andromeda Galaxy. It is the closest spiral galaxy to our own at 2.5 million light years away. And since you've already watched Power of 10, you have an idea of what a light year is. It is expected to begin colliding with the Milky Way, so our galaxy, in about 4 billion years. This is the Milky Way over Ontario. Next time you see the Milky Way in the night sky, you know that you are looking into the heart of your galaxy. We've guided our alien friend to the Milky Way galaxy. Where to now? The next category on the scale of things is stars. So, what are stars? I can't even begin to tell you how lucky we are to be born in our day and age when we know all of this stuff, but at the same time, I think we miss out a little bit on the magic of it all. Imagine living a few thousand years ago and looking up into the night sky. No light pollution, no smog, and absolutely no idea what the stars are. They would seem so magical. The ancients have been looking up at the night sky and wondering about these stars for millennia. In fact, they have many, many, many stories about stars, the origins of stars, and what they were representing. Let's do a little activity. Have you ever tried counting the stars at night? You lay on your lawn on a warm summer evening, look up into the sky and you just start counting? Well, let's pretend you have in case you haven't. And also let's pretend it's dark enough during the day so that you can see all of the stars all day long, all day and all night. And you decide, hey, I'm going to count the stars today. How many stars could you count in one day? If you can count one star per second. 24 hours a day, 60 minutes per hour, 60 seconds per minute. One star per second. So we've converted hours into seconds here. So you get 86,400 stars that you can count in one day. Well, that's a lot. Do you think you'd be able to count all of the stars? Probably you can count all the ones you can see, but let's say that your eyes are more powerful than the average human. Let's say you can see every star in the Milky Way galaxy. Do you think you can count them all? Do you think there is 86,400 stars just in the Milky Way galaxy? No, there's more than that. So let's try this one. How about we count the stars straight for 1 year? Somehow you're transformed, you don't need to sleep anymore, no more eating, nothing else. Your whole life's purpose was to count stars for a year. And it's dark, so you can do it during the daytime too. How about we do 1 star for each second? So if we go with that, let's say there are 365 days in the year, and that will give you 31,563,000 stars. But let's put the leap year in too, and so you get an extra day of counting stars. And take an average, 31,556,926 stars. So did we get that? Is that even close to how many stars are in the Milky Way? No, not yet. All right. You are very determined. You decide that this is a noble goal and worth your time, so you give up everything else. You don't eat, you don't sleep, you give up your job. Your very reason for existence is to count stars. From the day that you turn 15 until your 100th birthday, 85 years, how many stars would you have counted? Wow, 2,682,338,710 stars. That's a lot of stars. You've definitely counted all of the stars in our galaxy, right? Your life's work? No, sorry, but that's only barely 1% of the total number of stars in our galaxy. This number is huge. Let's say you get some help. Let's say you get the world. How many people are in the world? Well, let's be safe here and go with 7 billion. If I was able to recruit everyone on Earth to count stars straight for 85 years, we would be able to count 18 quintillion, 776 quadrillion, 370 trillion, 970 billion stars. Now that's a lot. Did we get it? The number of stars in the Milky Way? Oh yeah. Remember, all by ourselves we are able to count approximately 1% of the stars. 100 of us counting for 85 years would count the number of stars in our own galaxy. So what about 7 billion of us? We were able to count the number of stars in the universe. 18 quintillion, 776 quadrillion, 370 trillion, 970 billion versus about 46 stillion. Wow, not even close. It would take 2,000 Earths, each full of 7 billion people counting straight for 85 years to count the ridiculously large number of stars in our universe. So what is the moral of this story? You're a speck living on a particle orbiting a dot, one dot among trillions and trillions of dots in our vast universe. We know that stars come next. What is the nearest star to Earth? Where are we going to tell our alien friend to go? Right, the sun, Sol, S-O-L. That's the name of our star. So we have the universe, then we have the galaxy, and we're in the Milky Way galaxy. We never really defined galaxies. They are large collections of stars and dust held together by gravity. Then we have stars, which are giant nuclear furnaces slamming atoms together. We'll get more to that later. After stars, we have planets. Our planet, of course, being Earth. You may have already remembered hearing this sometime in the past, but how far away from Earth is the Sun? Almost 93 million miles away. 93 million miles. That's also known as one astronomical unit. Just like a foot has 12 inches or a meter has 100 centimeters, an astronomical unit has 93 million miles, or the distance from the Earth to the Sun. And isn't it amazing that even 93 million miles away, the Sun is still so bright that you can't even look at it? And 93 million miles away, the Sun is still so hot that it can torch us on a hot summer day. 93 million miles away. It's amazing. It takes sunlight or light 8 minutes to travel from the sun to the Earth. That's how fast light can travel. So that's why we can use light year as a measure of distance as well, especially really, really large distances like we find in the galaxy or even just our solar system. If, say, for example, our sun blew up or a solar storm or something happens on the sun, it would take 8 minutes for it to reach the Earth. Congratulations, you have helped our little alien friend reach our little neighborhood in space. Quick recap. Going from the largest to the smallest in the universe. What's after the universe? What's the next smallest? Galaxies. And then comes stars. And then planets. Now that we've had a brief overview